My dear students, how can you solve this problem? Directly by seeing the question. And this is a textbook solution. आप बगैर टेक्स्ट बुक सॉल्यूशन देखे के इतना आसानी से बगैर कोई कैलकुलेशंस के डायरेक्ट सॉल्व कर सकते हैं. I'll tell you short trick for this. यहाँ पर देखिए, this is a potential, battery. These are the capacitors C and C. ये दोनों कैपेसिटर्स है जिसका कैपेसिटेंस सेम है. कैपेसिटेंस सेम है. पहले ये कैपेसिटर बैटरी को कनेक्ट होगा, इसमें से पूरा पोटेंशियल यहां पर जमा होगा इधर, एंड आफ्टर दैट दिस की इज ट्रांसफर्ड टू द सेकंड कैपेसिटर. इट इज ट्रांसफर्ड टू द सेकंड कैपेसिटर. देन व्हाट हैपेंस? द क्वेश्चन इज हाउ द पोटेंशियल व्हिच हैज बीन कलेक्टेड फ्रॉम द बैटरी में से जो पोटेंशियल कलेक्ट हुआ है ये दोनों कैपेसिटर्स में से किस तरह डिवाइड होगा. हाउ द रेशियो विल बी डिवाइडेड. And it is said that the two capacitors having same capacitance. अगर दोनों की कैपेसिटी अगर सेम है तो फिर करने की क्या जरूरत है. डायरेक्ट आंसर बोल सकते हैं इसमें 50%, इसमें 50%. कितना एनर्जी होगा इसके अंदर? 50%. कितना एनर्जी होगा इसके अंदर? हाउ मच एनर्जी विल बी देयर इन ईच एंड एवरी कैपेसिटर्स? जस्ट 50%. So it absorbs the energy from a battery and this energy has to be shared equally because they are having same capacitance. That's it. एनर्जी कितना है इसके अंदर? 50%. It gives 50% energy to that capacitor and holds 50% with it. अपने पास 50% रखेगा और दूसरे को 50% देगा. फिर इसको सॉल्व करने की क्या जरूरत है? You need to solve this problem. Hope you have enjoyed this. One of my students asked, what is the solution for this type of non-Wheatstone bridges? What is the meaning of non-Wheatstone bridge? Here it is given that this is 2 and this is 10 and this is 10 and this is 2 and this is again 2. If the data is given, it's an unbalanced Wheatstone bridge. You all know about that because 2 by 10 is not equal to 10 by 2. It's not a Wheatstone bridge. Then it's very complex to find out the solution for this. We have to use delta star trick. If you are an IIT student, IIT students will use delta star trick. It's very difficult for BPC students. So I have got a solution for that also. There is a shortcut you can get in any of the books. This shortcut, if you use, you'll get the answer very easily. And I have solved this by using the shortcut. And you got the answer as 4. Thank you very much. My dear students, see the traditional methods given in the books. These traditional methods will waste a lot of your time. I'm going to use latest short tricks methods. So you can just see it. You can solve the problem without even solving the problem. How can you solve this problem? Let me discuss about that. See here, find the potential across each capacitor. How can you find out the potential across each capacitor without even solving the problem? The easiest method is, this is 60 volts, okay, 60 volts, and these two are parallel connections. That means among these three also 60, among these three also 60 volts, okay. But you know that all the three capacitors are same, but bottom or it is top. Then what happens? This 60 is exactly divided among the three capacitors. That means this will get 20 potential. There is 20 volts, 20 volts and 20 volts. This also will get 20 volts, 20 volts and 20 volts. That's it. Find the potential across each capacitors means it is just 20 volts. 20, 20, 20, 20, 20, 20. Each capacitor is getting 20. Hope you have enjoyed this. Thank you very much. Students, some of the students requested me to do the problems of combined capacitors and resistors like this. How can you do these problems without pen and paper? Some of the students requested me in description. Okay. So if you want such type of requests that you want to solve in particular chapter, you can just comment below. I am ready to solve the problem if I find the time. Okay. So how can you solve this problem without pen and paper? It's so simple. Appears to be so complex that students will leave this problem and come out because there is a capacitor here. We can eliminate this wire. The middle one, we can remove that one. There is no such case here. This part of the wire can be removed, cannot be considered. Nothing is there in that because as the battery is direct current, DC, so you know that capacitor does not allow DC currents. It does not allow the DC currents. So capacitor will be just like an open circuit. Then what happens, it's very simple. The current I is going to be net EMF by net resistance. What is the net EMF? You can just see here, this is 16 and this is 8, and the directions are directly opposite here. Okay, as the directions are opposite, you have to just make the difference of these two, that is 16 minus 8, and you have to add the resistances. Okay, so you have to add the resistance, 9 plus 3, that's it. Your answer is ready. So 16 minus 8 is how much? 8. And this is going to be how much? 12. Okay. So 4 2s are 8, 4 3s are 12. So your answer is 2 by 3 amperes. That's it, isn't it? So 2 by 3 amperes means you'll be getting B option. Hope you have enjoyed. Thank you. My dear students, these are the popular circuits which are given in many of the examinations like JEE Mains and NEET. So how are you going to solve the problems when they are complex circuits like this? You all know these circuits will eat away your more than 1 minute. So what you have to do is, a simple thing is, you have to remember the gunshot formulas for them. For example, if it is a star, it is 7R by 2. If it is this type of hexagon, it is 4R by 5. If this is just like a square shaped, this rhombus shaped circuit, and then it's 3R by 4. And if it is the pyramid shaped circuit, it is 8R by 7. If you remember these formulas, what is the benefit? What is the benefit? The benefit is, for example, if this resistance is taken as 2 ohms, if all the resistors in this circuit is taken as 2 ohms, then the simple thing you have to do is 7 into 2 by 2 gets cancelled, your answer is 7 ohms, it is ready. You can do this in 5 seconds. For example, if the resistance in each and every resistor in this circuit is 5 ohms, then your answer is 4 into 5 by 5. The answer is going to be 4 ohms. That's it. So simple it is. For example, if each and every resistance is 4 ohms in this rhombus, then you will just do 3 into 4 by 4. 4 gets cancelled. Your answer is 3 ohms. Then in this circuit, for example, if the resistance is taken as 7 ohms, each and every resistance in the pyramid is taken as 7 ohms. The simple thing you have to do is 8 into 7 by 7. 7 gets cancelled. It is 8 ohms. Then you might be thinking, sir, how exactly 2, 5 and this 7, that 4 is given in the exam? Yeah, most of the time it is given. Because he wants the NEET students to be very simple in calculations. Very simple calculations will give you. That's why he will give such a calculation that you will be getting cancelled. Cancellation will be done. There is very simple way. So hope you have enjoyed this one. Thank you. My dear students, let us see that there are the 2 charges given. In the question it is given there are the 2 charges, Q and 16Q. This is a smaller, that is a larger one. You have to find out the null point. Null point means neutral point. Neutral point means, for example, if you keep some other charge here, it should be at the neutral position. That means this is applying the force, that is also applying the force. The net force acting on that charge is going to be 0. That is called as null point, and it's also called as a neutral point. How can you find out the neutral point? Let us imagine the distance here is x from the smaller charge. From the smaller charge, where is the null point? The formula is x is equal to d by square root of q2 by q1 plus 1. This is going to be your shortcut formula. What is the distance? Distance between the 2 charges is going to be d. And what is q2? q2 is nothing but 16q by q1 is nothing but q, and this is going to be plus 1. Then your answer is going to be d. This q gets cancelled. Root 16 is going to be 4 plus 1. So your answer is going to be d by 5. So here from the smaller charge, this is the formula applied to get the point, neutral point from the smaller charge, and that is going to be d by 5. If we ask in the question the distance of neutral point from the larger charge, it's very easy. That means you have to find out d minus d by 5. Because this distance is d and this is x, which is taken as d by 5. From d, if you remove this d by 5, you will get the remaining answer as 4d by 5. With this it is there, the conclusion is from the smaller charge, neutral point is going to be d by 5. From the larger charge, neutral point is going to be 4d by 5. That's it. So simple it is. If you want one more problem you want, you can just see. One more problem is ready. See here, again if you consider Q and 4Q, there is one charge, there is another charge. This is Q and this is 4Q, and the distance between them is D. Let us imagine this is going to be the neutral point. Okay, so what is this? This is going to be the neutral point, and you have to find out the distance x from the neutral point, from the smaller charge. How are you going to find out? The same formula you have to use. What is that formula? The distance of neutral point from the smaller charge is x is equal to d by square root of q2. q2 is nothing but 4q. q1 is nothing but q and plus 1. q gets cancelled. d by 2 plus 1, that is d by 3. My dear students, first I will discuss a shortcut method explanation, and then I will discuss how we have created the shortcut, and I will discuss two examples so that you can apply on this shortcut and get the answer. So first of all, shortcut explanation of this concept here. The concept is said to be the null points, or it is also called as neutral points. What do you mean by this null point and neutral point? See, this is a charge q1, that is a charge q2. Then what happens here? There is one point in between these two charges. That point is said to be null point. What is the meaning of null point? Null point means the point where the net electric field intensity is going to be 0. Or the electric field intensity, because the first charge at this point is counterbalanced by the electric field intensity of the second charge at that particular point. That is called as a null point. So here, let us imagine this distance is taken as x, and this remaining distance is taken as d minus x, because from here to here it is taken as d here. Then how can you find out the null point from the smaller charge? This is said to be the smaller charge, this is taken as the bigger charge. Always null point can be found from the smaller charge. So the formula for that is, so electric field intensity because of first charge is counterbalanced by electric field intensity because of the second charge. Then here, you all know the formula for electric field intensity is nothing but q1 by 4 pi epsilon naught into x square. From here to here it is x square, and from that second charge, that is taken as q2 by 4 pi epsilon naught into d minus x whole square. It is d minus x whole square. Then 4 pi epsilon naught gets cancelled. Then what is left? It is q2 by x square is equal to this q1 by x square. It is q2 by d minus x whole square. q1 by x square and q2 by d minus x whole square. That's it. So take this d minus x in the numerator by x whole square is equal to q2 by q1. So d minus x, if you partially divide them, you will be getting d by x minus 1. This square sent to that side, it is going to be q2 by q1. Therefore, d by x is equal to square root of q2 by q1 plus 1. Okay, so if you make it reciprocal, x by d is equal to 1 by square root of q2 by q1 plus 1. And our aim is to find out what is x. Therefore, x is nothing but this d, if you send here, it is going to be q2 by q1 plus 1. If both the charges are same, that means this is positive and this is positive, you will get positive at this place. Okay, and if this is positive and this is negative, for example, you will get minus here. That is the concept here now. So therefore, in general we can write x is equal to distance divided by square root of bigger charge by smaller charge plus or minus 1, okay. Then what happens? That means q2 should be always bigger charge. Bigger charge comes in the numerator and smaller charge comes in the denominator. Okay, so plus you will get plus when the charges are same, you will get minus when the charges are opposite. So this is a concept explanation. Next I will discuss two shortcuts related to this topic. My dear students, let us see that there are the two charges given. In the question it is given there are the two charges Q and 16Q. This is a smaller, that is a larger one. You have to find out the null point. Null point means neutral point. Neutral point means, for example, if you keep some other charge here, it should be at the neutral position. That means this is applying the force, that is also applying the force. Then net force acting on that charge is going to be 0. That is called as null point, and it's also called as a neutral point. How can you find out the neutral point? Let us imagine the distance here is x from the smaller charge. From the smaller charge, where is the null point? The formula is x is equal to d by square root of q2 by q1 plus 1. This is going to be your shortcut formula. What is the distance? Distance is between the two charges is going to be d. And what is q2? q2 is nothing but 16q by q1 is nothing but q, and this is going to be plus 1. Then your answer is going to be d. This q gets cancelled. Root 16 is going to be 4 plus 1. So your answer is going to be d by 5. So here from the smaller charge, this is the formula applied to get the point, neutral point from the smaller charge, and that is going to be d by 5. If we ask in the question the distance of neutral point from the larger charge, it's very easy. That means you have to find out d minus d by 5. Because this distance is d and this is x, which is taken as d by 5. From d, if you remove this d by 5, you will get the remaining answer as 4d by 5. With this it is there, the conclusion is from the smaller charge, neutral point is going to be d by 5. From the larger charge, neutral point is going to be 4d by 5. That's it. So simple it is. If you want one more problem you want, you can just see. One more problem is ready. See here, again if you consider a q and 4q, there is one charge, there is another charge. This is q and this is 4q, and the distance between them is d. Let us imagine this is going to be the neutral point. Okay, so what is this? This is going to be the neutral point, and you have to find out the distance x from the neutral point, from the smaller charge. How are you going to find out? The same formula you have to use. What is that formula? The distance of neutral point from the smaller charge is x is equal to d by square root of q2. q2 is nothing but 4q. q1 is nothing but q and plus 1. q gets cancelled. d by 2 plus 1, that is d by 3. My dear students, let me solve this problem with a simple analogy. Okay, not with a complex method. With a simple method we can solve this problem. What is the problem actually? Let us try to understand. Okay, so here if you see, there is a copper rod, there is a aluminum rod. Okay, they are independent of temperatures and their alphas are given. You all know one simple thing here. Alpha is equal to delta L by L into delta T. What is the meaning of this formula? See, coefficient of expansion is nothing but increase in the length by actual length into rise in temperature. It's a simple question actually. Increase in the length and temperatures are going to be constant, independent. At all temperatures, their increase in the length is going to be same. Then what happens? Their increase in the length is going to be same at all temperatures. Then if these two are going to be constants, what is left now? Only alpha is inversely proportional to length. Okay, and is asking us to find out the length of the aluminum rod. Okay, this is inverse relation. If you observe here, it is going to be inverse relation. Then what happens? See, then what happens, you know, length of aluminum divided by length of copper is equal to alpha of copper by alpha of aluminum. That's it. That means length of aluminum is nothing but alpha of copper by alpha of aluminum into length of the copper. That's it. You send this, that's fine. Alpha of a copper, you know, See, this is 10 power 5, this is also 10 power 5. Need not write that one. Directly you can write alpha of a copper is 1.7 divided by 2.2 into length of the copper. What is the length of the copper given here, isn't? What is given? Yeah. So it is given as 88. So that's it. 88 if you write. If you calculate, you will be getting 68 centimeters. Okay. So therefore, your correct answer is 68 centimeters. It's a simple method to solve the problem. I don't say this is a shortcut, but I can say this is a simple method to solve the problem. If you remember just one thing, this problem is going to be very easy for you, in which there are two convex lenses made up of glass whose refractive index is 3/2, and there is a liquid, that is water, in between, that is a concave lens whose refractive index is 4/3. Just remember only one thing: for a concave water lens, focal length is minus 3f/2. If you remember this point, the problem will become dead easy for you. And already it is given that focal length of these two lenses, that is f1 is equal to f3 is equal to f given. And for water lens, the gunshot formula is, it is 3f/2. That is enough for you to solve the problem. Then you know net focal length is going to be 1/fn is equal to 1/f plus second one is going to be negative lens, so we can write this as 3f/2 plus again 1/f. So therefore 1/f net is equal to 3f as an LCM, so 3 minus 2 plus 3, therefore 1/f net is equal to, here it is going to be how much? 6 minus 2 is going to be 4/3f, therefore f net is equal to 3f/4. Your answer is this one. My dear students, let us solve this problem in a super simple way, and you will be amazing that how can we solve this problem such a simple way, and it takes only 5 seconds to solve this problem. You can just see the beaker. It's made up of bakelite. Beaker is made up of bakelite. It is having a mercury inside, and it is said in the problem that bakelite and mercury are expanding equally. That means if bakelite is half filled, when you heat from below, what is happening? Expansion of bakelite, expansion of mercury, both are equal. Understood what I am telling? If expansion of beaker is increasing, mercury is also increasing equally. It is increasing equally. Then what happens? There is a formula. Gamma is equal to delta V by V into delta T. What is the meaning of this? Coefficient of expansion, volume coefficient of expansion is equal to increase in the volume by actual volume into rise in temperature. But increase in the volume and rise in temperature are considered to be constant. Increase in the volume and rise in temperatures both are equally increasing, so that's why they are considered to be constants. Then what happens? Only the relation will be regarding gamma. Gamma is inversely proportional to volume. Gamma is inversely proportional to volume. What is the meaning of that? He is asking us to find out the volume of the mercury. So volume of the mercury divided by volume of the bakelite is equal to gamma of the bakelite by gamma of the mercury. That's it. So therefore here volume of the mercury is equal to gamma B by gamma M into volume of bakelite. That's it. Then what happens? See, gamma of bakelite beaker, it is given as 6 into 10 power minus 6. Okay. Divided by mercury is how much? It is 1.5 into 10 power minus 4 into volume of a beaker. Its capacity is taken as 500. It is taken as 500. If you solve this one, you will be getting 20 centimeter cube, or it can also be taken as 20 cc. That's it. It's a simple analogy to solve the problem. I can't say this is a shortcut. It's a simple and easy analogy to understand the concept. Thank you. My dear students, how can you solve this problem without pen and paper? Yes, by seeing the question you can solve the problem. The correct answer, how can I say that the correct answer is A option? This A option is going to be the correct answer. By just seeing, I can tell. And what is the concept behind that? What is the reason which is required so that you can solve the problem without even pen and paper? How can I do that? Now let us see here. For a complete circle, magnetic field at the center, the formula is mu naught I by 2r. Mu naught I by 2r. For a complete circle, this is mu naught I by 2r. But if you observe here, this is only half circle. For a half circle, you have to consider the formula is half of mu naught I by 2r. That's it. Need not by heart anything. For complete circle, if this is the formula, for half circle, half of the previous formula, therefore your formula is going to be mu naught I by 4r. Mu naught I by 4r. Here, if you observe, one circle, in one smaller circle, the current is moving in this direction. So 4 fingers, if you keep like this, thumb is going to be inside. This is called as Ampere's right hand thumb rule. 4 fingers according to the wire, thumb is inside, and the remaining, the larger circle, the current is moving in the anti-clockwise direction, thumb is outside. Okay, thumb is going to be outside. Now, then whose magnetic induction is larger, smaller one or larger one? By this formula it is understood that B is inversely proportional to R. The greater the radius, the lesser is the magnetic induction. That means larger circle is having lesser magnetic induction compared to the smaller circle which is having greater magnetic induction. Lesser the radius, greater the magnetic induction. Therefore, your answer is B net is equal to mu naught I by 4 if you common out. The larger one will be first, the smaller one having larger magnetic induction will be first, and the larger one whose magnetic induction will be less is going to be the next one. So therefore, your correct answer is this one. These concepts you need not solve. Just by seeing the question you can do if you follow the simple logic which I have explained. Thank you very much. My dear students, today I would like to discuss about a mean free path. Mean free path, which is very important topic. You can just see how many questions are asked in NEET. Even JEE mains also have seen many questions based on this. It's a very simple and easy topic. I will give you a shortcut explanation. This is not a shortcut video of problem. This is a problem. This is a video of a shortcut explanation. Now let me discuss here now. You have taken a cylinder in which the molecules are present. They are taking multiple collisions. Then what is the meaning of a mean free path? Mean free path means length of the cylinder, imaginary cylinder in which collisions have been taken place, and divided by number of collisions in the volume of a cylinder V. Okay, and this is going to be area of cross section of a cylinder. So mean free path is nothing but length of an imaginary cylinder in which collisions have been taken place divided by number of collisions in the volume of that cylinder. Therefore, lambda is equal to L by N, and volume is nothing but area into length. Volume is nothing but, it is going to be area into length. So therefore, lambda is going to be, LL gets cancelled here, 1 by N pi d square, because here the radius of a cylinder is taken as d. D is not a diameter here. D is taken as radius of a cylinder here. That's it. So your answer is ready. Your formula is ready. But you have to add one more constant here. You have to add one more constant. What is that constant? That is, in this formula you have to add even root 2 also. One constant you have to add in the denominator. That means your formula is ready. Now you can solve this problem very easily. You can tell the answer very easily that here mean free path is inversely proportional to d square, and mean free path formula is also known to you. Yes, the formula is also known to you. That's it. In 5 minutes, you learn the concept as well as 2 problems. This is called a shortcut explanation. Thank you very much. Have a nice day, baby. My dear students, this is a problem of photoelectric effect. This is a previous year problem asked in NEET. And you can see the lengthy solution given in the books. I'll solve this problem even without pen and paper. And you all know this is a photoelectric equation. First, let me solve the problem without pen and paper and then explain how I have got the solution. That's the concept here. Here, light is having frequency 2 nu naught. And nu naught is the frequency of a threshold frequency. And the frequency of sunlight is increased to 5 nu naught. Okay? The concept here is, from the photoelectric equation, you'll get energy coming from the sun is equal to work function into kinetic energy. When the light coming from the sun falls on the metal plate, electrons will come with high velocities. Okay, so this is taken as energy coming from the sun, and this is the work done to remove the electrons from the metal plate, and the electrons will ooze out with high kinetic energies, and E is equal to W naught plus half mv square is the photoelectric effect. You know about that. So this is an equation, photoelectric equation. You are very familiar with this equation. Now I am going to solve this problem without this process. How? Let me tell you. The simple method is, he's asking us to find out the ratio of velocities. V1 by V2 is equal to, you have to consider this is 2 nu naught and this is nu naught. 2 nu naught and nu naught. So we write 2 minus 1 divided by 5 minus 1 under root, because this is the concept here. Velocity is directly proportional to square root of frequency differences. Frequency differences. Frequency of the sun, frequency of the threshold frequency. So therefore, you just, in a single step, you can solve this problem. That is V1 by V2 is equal to square root of 1 by 4. Your answer is 1 by 2. That's it. My dear students, whenever this type of problem will come, a simple trick is, you have to apply I is equal to 3V by 2R. Whenever there is an equilateral triangle having equal resistance and there is a potential given here, the formula is just 3V by 2R. Your answer is ready. Or is 3 into V. V is nothing but 2. So 3 into 2 by 2 into R is nothing but 3 here. So 3, 3, 2, 2 gets cancelled. Your answer is 1 ampere. That's it. My dear students, whenever this type of hexagon shaped resistances will come, in which diagonals are present, in which all the diagonals are present and all the resistors are same, then there is a shortcut formula. You have to find out here resistance across AB is going to be R by 2. That's it. The shortcut formula is resistance across AB is nothing but R by 2. If all the resistors are same, then each and every resistance is taken as 2 and by 2 is equal to 1. This is a shortcut formula. Hope you have enjoyed this shortcut. My dear students, if this type of complex circuits are asked, then the simple method is, you have to remember a shortcut formula and solve the problem in just fraction of seconds. In just 1 second you can solve this problem. You can just see here, if this is a star shaped capacitors connected in the form of a star, and if the capacitance of each and every star is 7 microfarads, then you can write the formula, it is 6C by 7. Directly you can apply the formula 6C by 7 and you can save a lot of time here. 6 into C is nothing but 7 by 7. 7 gets cancelled. 6 microfarads is going to be your answer. For example, here each and every resistance in a star is going to be 2 ohms. Then you can apply a shortcut formula, that is, it is going to be 7 into 2 by 2. Your answer is going to be 7 ohms. Similarly, if you can see this circuit here, first one, if you consider, if resistance of each and every resistor in a pyramid shape resistor capacitance connected, if it is this case, then resistance is going to be 8R by 7, and your formula, you are going to apply the formula here 8R by 7 and directly write is, as the resistance is going to be 7 ohms, you can write 8 into 7 by 7, 7 gets cancelled. Your answer is going to be 8 ohms. For example, if the resistors are connected in the form of a square having diagonals here, and any bottom 2 edges you want to find out the resistance, your shortcut formula is 8R by 15, and you can directly apply the formula. If resistance is 15, you can write 8 into 15 by 15, 15 gets cancelled. Your answer is going to be 8 ohms. A very simple shortcut formula. You can just see if the pyramid shape is like this, then what happens? Just now I told you, this is, you observe here, if it is 8R by 7, it is 7C by 8. There is some reciprocity here. If it is 8 by 7, that is 7 by 8 here. Here also reciprocity. If it is 8R by 15, it is going to be 15C by 8. So these are the shortcuts you have to apply here. Now for example, if capacitance is going to be 8 microfarads, you can directly apply the formula and write 7 into 8 by 8, 8 gets cancelled, your answer is 7 microfarads. If the capacitance of this type of square shaped capacitor having the diagonals, whose capacitance is 8 microfarads, you can just apply the shortcut formula and write 15 into 8 divided by 8, 8 gets cancelled, your answer is going to be 15 microfarads. Like this you can create or remember shortcuts and solve any problem within fraction of seconds. Hope you enjoyed. My dear students, see the general method which is given in the books. Is asking us to find out the minimum wavelength of Lyman series as well as Balmer series. For that you have to follow this method in the books. But let me discuss a simple shortcut method where you need not use your pen and paper also, directly you can get the answer. What is that? Let me discuss about that. For that what we need to do is lambda of Lyman by lambda of Balmer is equal to principal quantum number of Lyman, principal quantum number of Balmer whole square. And for Lyman it is n equal to 1, for Balmer it is n equal to 2. That's it, your answer is ready. It is nothing but 1 by 2 whole square, which is 1 by 4, which is 0.25. Okay, so you can bypass this method and get the answer directly. Thank you very much.